everyone, and welcome back to Atman Unlimited. It's autobiography time. I've been kind of putting this video off. I just don't like talking about myself that much. But some viewers have asked the questions. I got a couple of emails, so I figure it's a new year. Why not make an autobiography video and just let everybody know a little bit about myself. The YouTube channel has really taken off far faster than I ever thought it would. My goal was really only 100 subscribers maybe in the first year. If you look at the vast majority of YouTube channels out there, they're not really watched. So at the filming of this, we've got about 780 subscribers, and the channel's been going for about 8 months, I think, 7-8 months. I mean, definitely not, a million subscribers, or we didn't go viral. But for the content that is made on this channel, I think it's very successful. It's very niche content, but it's so critical for the people that need this content. I have not been able to find a lot of the videos that I've made out there, which is why I made them. So, a little bit about myself. I'll start back when I was a kid. I kind of had what a lot of people call the knack. I don't know. I just have it in mind for all things engineering, whether it be electrical, mechanical, any form of engineering. I kind of have a good capability to do it. And I kind of have the strange gift of just being able to sit down, look at it for an hour or a day, depending on how complex it is, and just kind of understanding it. It just clicks. I don't know why. It's just the way it is. My mother bought me a lot of building kits when I was a kid. One of them specifically, if you remember back in the 80s, was something called robotics. And I was building, counterweighted drawbridges and all kinds of weird stuff when I was like 5 or 6 years old. So I've just been kind of mechanically inclined and engineering inclined my whole life. So for my day job, my main money income job, my title is a systems architect. What I do is I'm a consultant. I'm hired by companies to come in and help them do test equipment, data acquisition, and engineering research and development. And most of my systems include some type of closed loop control system. And I primarily service the military and aerospace fields, which is why I've got so much access to a lot of great minds that have helped me out immensely, along my journey. So I've been doing the, systems engineering since I was, 20. So I've been at my current job for about 16 years now, and I've progressed. I started out as a junior engineer, and then worked my way up. Now I'm a systems architect, they call me. Along with that, I've made 3 presentations at National Instruments NI Week. So a lot of the work I do revolves around National Instruments products. If you're not familiar with National Instruments, they have a really great kind of out-of-the-box product line solution that includes FPGAs, embedded processors, computer software, and it's all revolving around LabVIEW. I'm also a certified instructor for LabVIEW and National Instruments products. I mainly teach the FPGA class and the real-time classes. They're offering a lot of online classes, so I haven't been doing a lot of teaching lately, but I am a certified instructor. So that's kind of what I do, for my day job. One of my big projects that I presented on 2 years ago, I think it was, we had an opportunity to help a company do an autopilot for a helicopter. So we used National Instruments hardware to fly a helicopter. And not a toy helicopter, but a full-size, real helicopter. I sat in the back seat, did the software. I worked with a great team of people that did all the mechanicals and the electricals. And we also had a really great test pilot. That was the test pilot / safety pilot. If things went hairy, he was in the seat to take over at a moment's notice. So it's kind of my history. So primarily, if you believe it, I'm a software guy. and that's where a lot of the Fusion post-processor stuff comes from. I can open up a post-processor and just kind of look at it and get it, and as long as I have the manuals for the machine, I can pretty much write a post-processor. So that's why we started out, if you notice, there was a lot of post-processor videos, kind of going back to what I know best. After software, I'm extremely versed in microelectronics and digital electronics, followed by high-powered systems, high-power control, motor control, permanent magnet synchronous motors, induction motors. We're getting into inverters now, so we're doing a lot of work with inverter control now. Inverter control is very, very close to motor control. They're almost one and the same. It's just your control inputs are a little different. Followed by that, very versed in hydraulics and pneumatics. And then probably my least strong subject is mechanical engineering. I just don't do a lot of mechanical engineering. I can hold my own, but I'm not going to sit down and do, free body diagrams and gear trains and, all that stuff. I've never done it. I'm not saying I can't do it. It's just, it would take me a little bit to ramp up, to be able to do that. And it's not my forte. I mainly stick to, software, electronics, power systems, control systems, stuff like that. So that's enough rambling about, my profession and about me. A lot of people want to know, how I got started in machining. Well, I also like to design stuff in my basement, and a lot of my knowledge and skill set that I have learned over the years have been acquired doing projects in my basement. So the project that got this going is way back in like 2004-ish. My wife and I took up scuba diving, and one of my personal traits or faults is I don't do anything small, as you can see. I go big on everything. Go big or go home. So along with scuba diving, my wife and I got into it very seriously. I can rebuild all my own gear. I've got all the tools to do it. I'm setting up a filling station to fill scuba tanks. I got the high pressure compressor. You saw me make some parts for that. So I go whole hog in just about everything. Well, when I started about, 2004, 2005, that's about 10 years ago, I wanted to make like the mother of all dive lights, and I think somebody called it that. And I chose to use a 150 watt high intensity discharge lamp, which is normally used in stage lighting. So I also, when I was in high school, I did the stage crew in theatrics, and I continued that for maybe a year after I graduated high school. So I had some familiarity with, spotlights and roboscans and how they worked. So I actually sourced a bulb that is normally used in stage lighting. And the first problem was, generating power for this bulb that runs off of batteries, because nobody makes anything like that. So that's where the electronics design came in. So here's a picture of the very first prototype. I basically just it's a breadboard slash, open circuit on a piece of plywood to where I could prove out all the separate circuits, that would make up the lamp control. And I've been working on this on and off, like I said, for the last 10 years. It took me the first, 3 or 4 years on and off to get all the electronics sorted out and to get it small enough and efficient enough to be able to make it hand carried. So after I got all the electronics working and I could actually power the bulb and light the bulb, I thought this thing was the greatest thing. It was awesome. It really, kicked some butt. So I said, okay, now we got to put it in a housing that's watertight so that we can take it underwater diving with us. So that's where this path started. With the help of some of my, military aerospace friends, they made some suggestions to me on how to design my housing and stuff. Well, unfortunately my design contains a lot of, complex geometry in it because, we don't do anything simple because we can't. But, it carried into the light. And again, because of the compactness and the size and the power, it had to be that way. So after I got my mechanical design done, I sent out the 3D models for quote. And I was getting quotes of anywhere from $10,000 to $20,000 for a prototype. The cheapest part that I could find was $500. And, don't have that much working capital. Just didn't have it at the time. So the project kind of sat on the shelf for a while. And then I, got hooked up with another very good friend of mine now, and he had Tormach. So I was able to, run some of the parts on a Tormach to make my very first prototypes. And that's how I got into machining, because I could not afford to, outsource the machine work. It was just, way cost prohibitive. When I got access to a Tormach, I still didn't have any CAD CAM software. This was before, Fusion 360 was even an inkling, I believe. I don't know when Autodesk started making it. So what I did is I actually cammed the part by hand. I sat there and I used two-dimensional drawings to generate all the tool paths, and I wrote all the G code for the part by hand. It took about a week, and I was able to, manufacture the first parts. I also had a very good friend of mine be able to machine some of the round parts on a lathe. So I was able to get some of the parts done by a very good friend, and he donated his time, so that was very appreciative. So we got it all in a housing, and we turned it on. It overheated. Not only did it overheat, but it got so hot that the bulb literally exploded. So if you're not familiar with high-intensity discharge lamps, they don't have a filament inside of them. They're just two electrodes that stick up, and you get an arc in the lamp. It's like welding. Well, the heat generated to generate that plasma arc is immense, and there's a quartz envelope around it. If the quartz gets too hot, it loses its strength, and then the pressure inside the bulb while it's operating is like 100 or 300 bar. It's something insane. It's a couple thousand psi. So the bulb just goes boom, and you get shrapnel all over the inside of the lamp, and then the bulbs contain a little bit of mercury, so then you have to worry about trying to clean all the mercury out of it so you don't get mercury poisoning. It's not a good situation when they explode. So then that was the next 3 years of trying to figure out how to cool this thing, because these bulbs are designed for convection forced air cooling. They're designed for a stage lighting environment, not being sealed tight in a can going underwater. So that was a huge, technological challenge to try to keep that bulb cool so that it will A, not explode, but more importantly, B, run run to its length of life, longevity, without detrimental to the bulb. A lot of the dive lights I found, they run very hot, and a lot of them can overheat. So we didn't want that to happen. So this is going to be the first public debut of what we're talking about here. So I took the camera out back behind the shop, and I took a bunch of different lights and shined them on the back of my shop so that you could get a comparison of what kind of light output we're talking about. Now, to keep it apples to apples, I set the camera in 100% manual mode. So the camera is using the exact same exposure, aperture, everything is identical from test to test. So in this first one, I'll show you, I just used the standard Ryobi incandescent flashlight. Can you see it? Not really. So that was the first one. So then the second one is going to be one of these tactical flashlights you see on TV. 1,000,000 candle power. You can run it over with a fire truck. We dropped it out of an airplane from 1,000 feet, and it still works. And you can deter your attacker. These guys. So here's this guy in full focused spot mode, which is about a light source. I don't know. I was about 25 feet away from the garage, so this probably would have been maybe 2 or 3 feet across. And you can barely see the square. And it's square because it's a focused element off of an LED element, and typically LEDs are square, the dies are square, so that's why you get a square light. But you can barely see it in the center of the frame there. So then let's move on to something more realistic. Okay, I pulled one of the lamps out of my machine. So these, if you're interested, these are the bulbs I use inside my machine. I just put two, standard Edison socket holders up in there, and they got a gasket. They're designed for wet environments, and these lamps are certified for wet environments. So don't worry, I'm not going to electrocute myself. I'll put the part number for the bulb right here. And this is a Sylvania bulb. You can buy them at Home Depot or Lowe's. And what this is, it's a 120 watt equivalent, but in reality what it is a 17 watt LED. So this is equivalent to a lot of the high-end, high-power underwater LED dive lights that you see. They run approximately 17, 20, maybe 21 watts. So in lighting fixtures, you'll find the term lumens a lot. But in reality, what I found is it's a very loose interpretation, and the salespeople get their hands on the specs, and they seem to be embellished a lot. So this lamp, I believe, is rated at 1300 lumens, something like that. Yeah, 1300 lumens, 5000 degrees Kelvin, that's color temperature, so this is very close to daylight. That's why the light inside my machine looks nice and bright and white, because I'm using a daylight bulb, not a warm white. That would be like an incandescent bulb or a warm white fluorescent, and they sell warm white LEDs. So that's this one, and you can see, now we've got some light being thrown out. And this is, AC powered, so I ran an extension cord back out there. So, that's what you get with one of these, and this is what you're typically going to see in one of these larger, high-end, battery-powered flashlights. So, this is the actual light that I've been working on and designing. I've got the back open. We're still working on some of the control. So, all these parts that you see are 100% machined here, and this upper part, all these upper parts are all made on my mill. This lower part is still the same one that I made on the Tormach years ago. We haven't had to change this lower section at all. This is the original one. So these are all upper. We've had to change the design of the upper housing to deal with the thermal effects. So now we've been able to get this to run in air, so holding it like this for about 25 minutes before it will overheat. And now the lamp no longer overheats. The electronics in the electronics bay actually overheat. The heat soaks back slowly into the electronics bay. So now we're starting to change some stuff back here. So, the goal is actually to get this to operate out of the water. So we can operate in the water forever. It doesn't overheat, and we've got about 100% margin. So unless you're scuba diving in about 150 degree water, it won't overheat, which is good. So we don't want to ever overheat, whether you're scuba diving in Hawaii or the Caribbean or all the way down to Antarctica. We want this to work all the time. So here's the amount of light you get out of this thing. Now you can notice that the center point is actually blowing out the exposure a little bit on the camera. I've got the 100% clear filter in there. So I don't think we're ever going to use this filter in production, if we make it to production. Just because you get a lot of lamp effects. You can see there's kind of some dead spots and some shadowing going on. I've had other filters made up that have a little bit of diffusion in them, and then I've got a 100% diffused filter if you just want general floodlight for videographing or whatnot. So the center point of this is just blowing the exposure of the camera out, and then you can see it's lighting up the whole back of my building. So where your uber tactical flashlight here, you can barely see it, and then, this guy kind of dimly lit the building. This is blowing out the center of the exposure, and it's also flooding the whole entire, back of the building. So you can see, what's going on here. And, this is really cool. The other use case for this is, mobile news. I've talked to a couple of mobile news camera people, and they kind of started salivating over this because, and it's not necessarily shooting at night, it's more shooting at dusk. So a lot of the feedback I got was, if we're doing a shoot and it's at dusk and we're far away from the truck, we can't use, so when they normally shoot at dusk, they use basically 150 watt or 200 watt HEID or HMI lamps. And they're powered by a generator. They're 110 volts or 120 volts, powered by a generator, and they got a generator in the news truck. But if they're far away from the news truck, they can't use those. So what they get is they get a lot of reds in their picture, and they don't have lights that are portable that are powerful enough to wash out those reds. This can wash out everything. Okay, so this portion here would be, what you would have to hold. It's a little heavy on land. We're working on getting the weight out of it. The last design, we've already shaved a pound out of it, and I'm actually getting more metal out of it. so that it is, starting to lighten up. And then you're going to have a cord that runs off the back, and then you have a separate battery. The battery, we're keeping nickel metal hydride for now so that you can fly with it. It uses a 240 watt hour battery, so you get over an hour burn time. You get about 70-minute burn time, which is really good for this type of power in a portable package. And the battery is almost about the same as this. It's about the same length, and it's about 4 inches in diameter. So the battery is manageable. It's not tiny, but it's manageable. For this type of power, it's very manageable. So this is what got me into machining. So after I made some parts on a Tormach, I said, oh man, I got to get myself one of these machines. And I was originally going to buy a Tormach. Then I started thinking about it more and more. To make a lot of my parts, I need approximately 10 to 15 tools. So if I were to buy a Tormach, the base model Tormach, I think, I'd have to buy the 1100. The other machines are too small to make the parts. They didn't have enough Y travel, I believe. So to make that on a Tormach, I'd have to buy an 1100. I think the base 1100 started at, they call it 8 grand or 9 grand. But then once you, buy the base, and then they want you to buy their own separate special computer because all of their control is done inside of a PC. I don't have a high opinion of that, but that's the way they chose to do it. For a machine, now you're talking, 12 grand. And then I'm like, oh man, I don't want to stand there and have to make these and, keep switching tools out manually, because some of the tool changes are pretty fast. You put a drill in, you drill 8 holes, and you put a tap in, you tap them, and you switch to a small end mill, you mill out an O-ring groove, then you switch to a chamfer mill, and you chamfer, or you switch to a radius tool, and you got to put some radiuses on stuff. So there's a lot of tooling involved in making a lot of these parts. Hence the price from the machine shops that I was getting, is because these are very complex parts. So then I started looking at, like a Bridgeport, and then, since I'm a software and electronic and electrical guy, making my own CNC machine. Well, again, you're talking almost the same price. You buy the Bridgeport, you're in for at least 2 or 3 grand for something that's, decent, okay? Then you got to spend another couple of grand for, motors and controllers, and, I wanted to do it right. I didn't want to skimp on it. So I was at a couple of grand there, and then how long is it going to take me to make? Because now I'm starting on this whole project, So I started looking at used commercial machines. So Bridgeport has a couple of kind of CNC machines that they sold where, it's just a Bridgeport with CN control on it. So I started looking at some of those. And, the prices were, insane. And even the prices for these machines, they're all over the map. You can find them pretty cheap, or you can find them very expensive. So like I said in some of my other videos, I had a friend of a friend who was selling the machine, and, price was right. We made a deal. I was able to get this machine. I've been very happy with it. So that's how, I've progressed. That's my professional background, how I've gotten here. So then, Atman Unlimited comes into play. So how did I go from there? Well, I said to myself, geez, I can't be the only person on the face of this earth that wants to design some products, wants to get some parts made, but, either, can't afford it from, a traditional machine shop, or for whatever reason it's too expensive, or the machine shop is too busy and they don't even want to call them back, because most of the time you want one to start with. And I thought, gee, well, maybe there's an opportunity here to try to provide maybe some lower cost, machining services to people that are like myself. So, but when you actually start looking at that and start going into it, now you start understanding why the machine shops, charge so much. I'm still cheaper by a good amount than most of the machine shops that quoted my parts, just because I've got a lot less overhead. I'm just one machine, in my home shop, so I can keep my overhead down. Therefore, I can keep my prices down. So that's where Atman Unlimited started. Around the same time I bought my machine, a little bit afterwards, my wife has been wanting an embroidery machine. Hence the sale of the shirts. By the way, if you want a shirt, send me an email, $25 plus shipping. We've sent out quite a few of them already. People are very happy with them. So she wanted an embroidery machine. Well, she's just like me. Go big or go home. So she didn't buy, one of the embroidery machines you see at, Joann Fabrics or, any of the small, fabric stores or craft stores. She went off and bought a professional, high-end embroidery machine. I think the thing has 16 needles. It's a sight to behold. I mean, it's almost as complex as this CNC machine behind me. So she started to embroider, more things for people. I started to, dabble in making parts for some people. So that's when we said, geez, we've got enough demand here now where we should start a company, be official, have that incorporated. So Atman Unlimited is a full corporation. We did that for, liability reasons and, structuring reasons, and there's a whole bunch of reasons, and even starting up a company. Everybody says, oh, it's easy to start up a small business. Well, you know what, until you go try it, don't talk. Because it was hard. There's a lot of paperwork, there's a lot of BS, and then I don't want to get into politics, but people in politics wonder why small businesses aren't starting. There's a small business association, so we went for a meeting there, and all they wanted to do was give us loans. And it's like, I don't need loans. I used my day job and saved my money, and, I bought, the stuff that I wanted with my own money, so I don't need loans. I've got the equipment. I just need to start my company up and get up and running. And a lot of people say, oh, that's a lot of money to spend. Well, a lot of people have a lot of different hobbies. I live kind of out in a rural area. So, which is why I can have a home shop pretty easily. Some people made some comments that, they could never have this, at their house. They're in an HOA, whatever. A lot of people around here have four-wheelers and snowmobiles, motorcycles, hot rods. Well, you look up the price of a snowmobile now or a four-wheeler, you're pretty much at the same price threshold. So, instead of my hobby being, snowmobiles, four-wheelers, hot rods anymore, I do this. One of the things that I did do is, I'm a car guy as well. I built a 1923 T-Bucket kit car. I used to drive heavy wreckers. I got a Class A CDL. So, I've pretty much done a lot. So that's where Atman Unlimited started. Now, a couple of people asked me, how do I get business? Well, my company is really young. We started last October, so we're just a little over a year old. I don't do a lot of business right now. A lot of people asked, how do you get business? So a lot of the business I have gotten so far for the machining side of things has been through business relations that I have at my day job. So I know a lot of people at a lot of different companies, and typically the companies that need software and help that way, they also need some machine work. So I've been able to do a little bit of machine work for some of those same customers as well. And I've got some other acquaintances and some personal friends that have small businesses, and we did some machine work for them. So that's how I've been getting a lot of my machine work. I have not done a lot of jobs, as Atman Unlimited. Yeah, a lot of the parts you see are, my own personal parts as a hobby. So that's where, some of my work comes from. Now, the market that kind of showed up at the doorstep was with YouTube. So my whole point of making the YouTube channel and spending the time for YouTube was to try to get some advertisement out of it. So some free advertisement. I put in some time on YouTube. I put a lot of time into on YouTube. I didn't know getting into this how much time it took, but I think it's been worth it. And I've been getting a lot of support, or been given a lot of support to people buying these machines and trying to rebuild these machines, because this information isn't out there. A lot of very generous people have donated stuff to us. We've had some hardware donated to us. A lot of people have made some personal one-time donations, which I greatly appreciate. They just send me an email and say, hey, I want to give you some money. I've gotten so much use out of your videos. I want to try to support you. So that's good. We've got the Patreon, which we just recently got some new patrons, so thank you. So we got that. And then a lot of people have been contacting me about post-processor mods. Now, I will say Autodesk does a fair good job of providing some generic post-processors, and they do a pretty good job at trying to do little changes on their forums. But if you have a machine that the post-processor, isn't close on, or you need some very specific stuff added to it, there's not a lot of help or support out there. So, unbeknownst to me, there was this market to do this, and I've actually gotten, quite a few jobs of just modifying post-processors for people. And so far, all the post-processors we modified, were all successful. So I'm kind of rambling on here. I'm sorry the video's getting long. But, that's about me, about my background, my day job, how I got started into machining, how I got the machine, how Atman Unlimited materialized and started up, how we get our jobs and leads so far. And here's looking forward. So I've gotten quite a few people that have contacted me recently looking for parts to get made. So, it's starting to take off now. And, that's good. Most companies that start in the first year, they don't make a dime. And that is very true in this case. We've done quite a few sales, and we've gotten some donations. All the money that we've gotten from our sales and donations are all going 100% back into the machine. Just ordered the ball screw. I said that last video. So I think that'll pretty much wrap it up. Again, I appreciate everybody's support, both from the personal donations and the shirt sales. If you want a shirt, send an email and we'll get you out a shirt. The personal donations are just, wonderful. I can't thank you guys enough. I appreciate it. And, moving forward in 2017, I look forward to making some more, great YouTube videos and spitting out some more parts on the machine. So, again, thank you for watching. Thank you for your support if you supported us. And if you'd like to support us, send an email, and, we appreciate it. So, we'll see you on the next video, and thanks for watching.